At what point would the Earth become a black hole? Pretty much anything could, in theory, become a black hole if it was squeezed down small enough. At what point would the Earth become a very unimpressive black hole in space? We're going to figure it out, and tell the tale of the Schwarzschild radius. A black hole is a region of spacetime where gravity is so strong that nothing, including light or other electromagnetic waves, has enough energy to escape its event horizon. The theory of general relativity predicts that a sufficiently compact mass can deform spacetime to form a black hole. The boundary of no escape is called the event horizon. Although it has a great effect on the fate and circumstances of an object crossing it, it has no locally detectable features according to general relativity. In many ways, a black hole acts like an ideal black body, as it reflects no light. Karl Schwarzschild, born in 1873, is one of those people who make us resentfully conscious of just how little we get done during our days. He was a well-respected professor of astrophysics in Germany, one of the major centers of physics research. Karl Schwarzschild was a German physicist and astronomer who investigated the mathematics which eventually led to the prediction of the existence of black holes. In 1916, Karl Schwarzschild found the first modern solution of general relativity that would characterize a black hole. He got some reading material, which happened to be Einstein's theory of general relativity. This theory has Einstein stating that massive objects distort spacetime, and that distortion is what we perceive as gravity. Schwarzschild considered this, and thought that a massive enough object packed into a small enough space could distort spacetime enough that not even light could escape it. He decided to go ahead and work out that relation of mass and the space it was packed into. He came up with the idea that the radius within which an object became a black hole could be calculated by doubling the object's mass, multiplying it by the universal gravitational constant, and dividing the entire thing by the speed of light squared. In other words, r equals 2gm_c squared. This technically means that anything can become a black hole, as long as it's compressed down enough. Technically isn't the same as practically. Recently scientists were surprised that a star 40 times as massive as the Sun failed to produce a black hole after its collapse. But, if we had some preternatural mass hugger out there, almost anything could be compressed into black hole if it got pushed within its own Schwarzschild radius. It would have to be a hell of a hug. To get the Sun to turn into a black hole, it would need to be pushed down to about 3 kilometers in radius. The Earth would need to be pressed into having a radius of 8.7 millimeters. One could think of that as very unimpressive, but I like to think of it as being like a tiny space assassin. Sadly, in 1916, Schwarzschild died of infection within a year of coming up with his eponymous calculation. He never got to see black holes, or wide acceptance of his idea. But he certainly got a lot done.